Welcome everyone again to AI in supply chain. The future belongs to supply chains that think and adapt in real time. Uh, as I said earlier, this presentation is excerpted from Architecting the Future of Logistics with A2A, MCP, and Graph Enhanced Reasoning. It's a substantial white paper. We urge all of you attending today, or if you're viewing this in a recording, to go to logisticsviewpoints.com and download the full white paper at download-the-AI in the supply chain white paper. Today, we'll be exploring how artificial intelligence is transforming supply chains. This isn't just about dashboards or analytical add-ons. It's truly about a structural shift in how global logistics operates. The future belongs to supply chains that can think, adapt, and act in real time. And once again, don't forget to download our white paper. And here's our agenda for today. In this session, we'll move step by step. First, laying the foundations of AI in supply chain, then exploring agent-to-agent communications, the model context protocol, and retrieval-augmented generation. We'll then cover graph RAG, data harmonization, challenges and risks, before finishing with a roadmap and a closing discussion. Supply chain context. Modern supply chains operate under constant strain. Lead times are unpredictable, disruptions are routine, and customers demand speed and transparency. Traditional methods have been brittle. Volatility is now the defining feature of supply chain management worldwide. Our first section is Foundations of AI in Supply Chains. The structural shift with AI. AI isn't a bolt-on solution. It's a structural shift. It allows us to see patterns across millions of variables. It allows us to reason in real time and adjust procurement, planning, transportation, and fulfillment dynamically. It's the bridge from rigid rules to adaptive intelligence. From rules to learning. Legacy systems are built on static rules. AI brings probabilistic, data-driven models that learn from history and real-time signals. These systems detect anomalies, anticipate swings, and recommend corrections beyond pre-scripted logic. They thrive where rule-based systems fail. Real-time optimization. AI optimizes across thousands of variables simultaneously. Think of dynamic routing that adapts to traffic and fuel prices, or procurement strategies that shift proactively to disruptions. Optimization at scale transforms complexity into a competitive advantage. Visibility across systems. Supply chains are exception-driven. AI predicts exceptions, initiates workflows, and escalates only when necessary. Continuous learning improves accuracy, and managing these exceptions well is the new measure of agility. Human and AI collaboration. The most effective supply chains don't replace people, they augment them. AI provides dashboards and recommendations. Humans apply the judgment and intervene when needed. The winning model combines machine speed with that human oversight. Our next section is A2A, agent-to-agent communication. Let's define A2A. Agent-to-agent communication, or A2A, allows AI agents to interact directly. Agents can request data, share information, and negotiate options. They can cover procurement, transport, inventory, and demand. This unlocks system-wide intelligence. So why does A2A matter? Well, traditional enterprise communication is rigid and manual. Disruptions cascade slowly. A2A allows rapid adjustments in seconds, improving customer outcomes through coordinated responses. Machines solve these problems without handoffs. What are some use cases for A2A? Dynamic replenishment, autonomous procurement, and real-time routing are key use cases. Agents balance stock, place orders, bid for transport, and escalate only if needed. A2A turns replenishment, routing, and sourcing into autonomous processes. What are some benefits of A2A? A2A reduces manual handoffs, speeds up cycles, and saves money. Multiple agents operate concurrently at network scale. Modular upgrades make it future-proof. And efficiency and adaptability then become the norm. Development efforts. Open agent architectures aim for interoperability. Multi-agent system frameworks support logistics. Cloud platforms are beginning to embed A2A. But of course, as we know, proprietary approaches still dominate. We're fortunate that standards are beginning to emerge to connect all of these. So what are some limitations of A2A? Data silos, trust issues, and legacy resistance all remain fairly significant barriers. Governance and liability questions are, for the most part, still unresolved. This challenge isn't just technical, it's really about trust and interoperability at scale. Next, let's examine the Model Context Protocol. So what is the statelessness challenge? Traditional AI lacks memory. It forgets past events, supplier reliability, or seasonal shifts. That creates inefficiency and mistrust. In supply chains, history does matter. Memoryless AI can't manage pattern-dependent operations. So what does MCP provide in that domain? Well, the Model Context Protocol, or MCP, gives AI memory, identity, and continuity. It retains facts, shares context, and allows AI to know what happened before and why it matters right now. How about some examples of MCP in practice? Well, forecasting agents recall seasonal anomalies. Procurement models remember supplier lead time issues. Customer service systems can track full delay histories. Thus, continuity improves trust, accuracy, and usability. What about using MCP with multi-agent systems? Well, MCP assures that those agents do in fact share context across interactions. It prevents duplication and conflicts. It makes decision chains traceable. This then transforms isolated tools into collaborative, truly collaborative decision makers. What are the benefits and risks of MCP? MCP improves accuracy and efficiency, but does require governance. Privacy, storage, and interoperability issues must be managed. Memory does add power, but it also adds responsibility. Next, let's examine RAG, Retrieval-Augmented Generation. Why is RAG needed? Well, models only know what they were trained on. Training data may be outdated or incomplete. Supply chains demand current precise data. Retrieval-Augmented Generation, or RAG, bridges this static training with dynamic reality. So how does RAG work? Well, RAG combines retrieval with generation. The retriever finds relevant facts. The generator produces answers grounded in those facts. Thus, this shifts AI from guessing to actual fact-based intelligence. What about customs and compliance? RAG retrieves current regulations and autofills documentation. It can cut days off compliance checks and can reduce costly errors. Compliance risks should shrink when AI retrieves the latest rules automatically. What about supplier and tariff use cases? RAG evaluates suppliers with live ESG ratings, sanction lists, and delivery histories. It dynamically retrieves tariff codes and trade restrictions. This ensures sourcing and routing decisions are fact-based. Let's examine architecture and tools in the domain. RAG uses retrievers, generators, and orchestration layers. Vector databases and large language models power the stack. But success really depends on maintaining reliable knowledge bases. So what are the benefits and the challenges of RAG? RAG does improve accuracy and compliance, but adds some latency and cost. Security and governance are critical. The benefits are huge, but they're not free. Now let's examine an extension of RAG, graph RAG. From flat RAG to networked graph RAG. Traditional RAG treats data as isolated chunks. Supply chains are in fact networks. GraphRag models nodes and relationships between those nodes, letting AI reason across dependencies, risks, and data flows. So what does GraphRag matter? In real supply chains, a supplier supports multiple products where port delays can ripple downstream or regulations target only specific product flows. Graph reasoning reflects this interdependence. Let's examine some GraphRag applications. These applications can include disruption analysis, strategic sourcing, compliance mapping, and inventory optimization. GraphRag specifically identifies those ripple effects and resilient alternatives. So how exactly does GraphRag work? Knowledge graphs model nodes, edges, and dependencies. The retrieval functions traverse these graphs. Event streams keep all of it updated. So the graph context then flows directly into the LLM outputs. What about benefits and barriers to GraphRag? Well, GraphRag does deliver holistic insight and explainability, but it does require clean master data and computing resources. The payoff is high, but the preparation can be high as well. Next, and perhaps the most critical part, is data harmonization and infrastructure. Why harmonization matters. AI is only as good as its data. Fragmented inputs produce unreliable results. Harmonization of shipment IDs, supplier records, product codes, and all that data accessible to the system is truly essential. What are some common data challenges? Supply chains face multiple versions of truth, inconsistent labeling, missing metadata, and incompatible formats. Inconsistent data undermines both trust and performance. So what are some steps to harmonize? Well, harmonize requires auditing, standardization, integration, and governance. It's a very disciplined process. You need to catalog data, enforce naming conventions, integrate systems, and assign ownership. But it's a very critical step in the process because without clean, trusted data, your AI functions will not give you a fact-based answer. So what tech stack tools and components are we talking about? Data lakes, ETL tools, extract, transform, load tools, MDM platforms, and APIs form the backbone. All of these components enable live AI-ready data flows across the enterprise, harmonized data flows. What are some examples and what risks are there? Well, Procter & Gamble unified over 100 feeds for forecasting, harmonized over 100 data feeds. Maersk built a digital twin of global data flows. And Unilever harmonized ESG, financial, and logistics inputs. Without this harmonization, all of these efforts would have stalled or perhaps failed. So, what are challenges and risks? Well, the first is data quality and governance, which we touched on earlier. AI depends on consistent, reliable data. Without governance, forecasts fail and compliance breaks down. Stewardship and schema enforcement are critical safeguards. What are some black box concerns? Well, this deep learning in AI can feel very opaque to human users. When operators don't understand AI decisions, they tend to ignore them. Explainable AI frameworks and logs improve that trust and adoption. What about organizational resistance? AI disrupts workflows and creates a fear of displacement for workers. Resistance is common, but training, augmentation messaging, and clear role design reduce that pushback and allow for greater effectiveness. What about integration complexity? Legacy ERPs and WMSs resist real-time interoperability. Integration issues delay return on investment. And modular architectures and APIs, when deployed, help mitigate all of these obstacles. What about security and regulation? Well, AI, unfortunately, does introduce new attack surfaces, new attack vectors. Unauthorized access, prompt injection, and data leaks are also continuing risks. Strong security and cybersecurity and compliance are essential from day one. And in fact, in an upcoming webinar, we'll be talking about cybersecurity and the supply chain next month. Next, let's look at a path forward and a potential roadmap. What do we need to do to modernize our digital backbone? Well, first, future supply chains must replace batch workflows with APIs and event streams. Cloud native architectures and unified data lakes are really the backbone of real-time intelligence. Harmonized databases and near real-time event streams. Then, of course, it's important to harmonize at scale. This requires system-wide audits, master definitions, and global standards. It's important to assign clear ownership for every domain because a unified version of truth, one unified version of truth, fuels the most impactful AI implementations. Then, how to build A2A protocols. It's suggested to develop modular agents with particular domain ownership, connect them with APIs, and pilot in one domain at a time before you scale. Coordination at scale demands that shared language and that harmonized data table, data lake. Then how to deploy MCP, Model Context Protocol reasoning. Well, MCP tags shipments, customers, and transactions with context. A persistent state then makes AI decisions traceable and repeatable. This continuity builds reliability. Human and AI collaboration. Dashboards and training humans to oversee AI is important. You really, to successfully achieve this, you need to define precise handoff points and emphasize transparency. The strongest supply chains use AI for leverage and not to replace human workers. Governance. What about governance frameworks? It's important to create oversight committees, audit performance, and review liability exposure. Governance ensures responsible AI scaling without chaos. And with that, we've concluded a very quick view over AI standards. So what did we learn today? We've touched on the fact that traditional models are giving way to adaptive frameworks. A2A, MCP, RAG, and GraphRag formed connected intelligence. The most resilient supply chains in the future will be those that are most aware. AI is reshaping logistics from reactive to proactive. The roadmap is very clear. Harmonize, connect, govern, and scale. AI in logistics is not optional. It truly will be the operating model of the next decade and decades to come. Thank you very much for attending today, and let's open the discussion. Remember too that this short presentation is an excerpt from our white paper about AI in the supply chain, and we urge all attendees today, as well as listeners in the future, to go to logisticsviewpoints.com and download the AI in the supply chain white paper for deep details into all of these topics. And with that, we will open it up to any questions that we may have.